Here's the actual cow's eye. It's considerably smaller than the model. It may be slightly bigger than your own eye. When you turn to the back, the posterior region, you can see the optic nerve. It's surrounded by all this fatty tissue, and that's true of your eye as well. That has to be removed. So cut away at it, making sure you don't puncture the globe, but just, it's a relatively quick process. Just pull it up and cut away at it, and don't dig your scissors into the actual globe. So looking back, what we've got, here's the optic nerve. You can see where an extrinsic eye muscle is attaching to the globe. And the globe itself consists of this wall of fibrous connective tissue, the sclera. You may find it easiest to make a small puncture with a scalpel blade, just keeping a bit of pressure on the eye. Jab it, and then you can cut with your scissors, cut around to make two halves. You will notice as I'm doing this, the contents of the eye has leaked out. That's okay. Just continue to cut till you've cut all around to make two halves. An anterior cup and a posterior cup. Let's put these aside for a moment. Here is the vitreous humour from the back of the eye, the lens and the ciliary body. We'll come back to that as well. Just move it to one side. This slightly viscous fluid is the aqueous humour, derived from the blood. It occupies the anterior chamber of the eye, providing as a source of nutrient, but its principal role is maintenance of intraocular pressure. Here are the two halves of the eye, the anterior cup and the posterior cup. Here is the lens, the ciliary body, and the vitreous humour. Let's look at the anterior portion first. You can see what would be the white of the eye, the most anterior part of the sclera. the iris and the clear part, which I'm lifting up, the cornea. Turning the eye over, you can see the iris. It's the change in the diameter of the pupil which the iris regulates. In so doing, it controls the amount of light which reaches the eye. Too much light will lead to damage to the retina, which is the sensory part of the eye. Insufficient light, and it will be hard to see anything. With a bit of luck, what you can do is pulling the cornea away from the iris, you can trim it off and look at it separately. Let's move on to the vitreous and the lens. I won't try and pick this up because it's quite gelatinous, but here is the vitreous humour. It's the vitreous humour which occupies the posterior globe. This is quite a good dissection because you can see quite a lot of this black material has remained intact. This black material makes up the ciliary body. The ciliary body controls the size of the lens, this single structure here. And by changing the size and shape of the lens, it ensures that light is focused on the part of the retina of greatest visual acuity. You should be able to pull the lens off away from the vitreous. Whoops. There it is. It's roughly spherical. And what you can try is putting it on some newsprint and see what effect that has. I'm going to go back now and look at the posterior cup. You can see these sort of black regions, and I'm going to do it very carefully, but hopefully you can see as I'm rubbing along a very thin layer is coming away. Here, this is part of it here. Hopefully you can see this little very fine membranous material. I'm going to just wait till I tip out some excess fluid. Particularly if you locate the optic nerve and locate where it comes to the eye, you can see here this thin membranous material. This is actually the retina. What I'm going to do is I'm going to try and cut it away. The best place to cut it is its point of attachment with the optic nerve. So it's hard to really see much structure here, because what's happened is when you've removed the vitreous humour, the retina has basically folded up on itself, which is why some people may experience visual problems when they have trauma to their head, because the retina becomes detached. Looking at the cup of the eye, you can see a very black region and this sort of pearly iridescent region. This pearly iridescent region is not a feature of the human eye. It's seen in things like cows, but also nocturnal animals. This whole structure is called the choroid. It's the structure which underlies the retina. And in an animal like the cow or nocturnal animals, this portion of the choroid is called the tapetum lucidum, and it's a reflective surface, so that when light travels into the back of the eye and through the retina, which would normally lie on top of this surface, light is reflected off the tapetum lucidum back into the retina. It's not very useful for animals like us because we are most active in the daytime, and in fact it would make our perception of vision a bit more confusing. But in animals which often need to have very good night vision, you will commonly find this tapetum lucidum. Once you've finished looking at all the structures, you should remove all the tissue into the wet bag, rinse off the cutting board and the instruments, and then you can proceed with the other parts of the class.